Hello, everyone, and welcome to High Frequency Trading System Design Architecture Series. My name is Posh, and I'm thrilled to have you join me on this journey into the fascinating world of HFT system design. So, till now, in this series for designing HFT systems, we are currently on the part two. In case if you have missed watching my part one of this designing this architecture series, please go ahead and watch that first, and then you can come back here. So, for the people who are watching this video for the first time, in this particular series, we are covering the blog post by Ariel Salahian, who is a very famous person when it comes to electronic trading and have been heading multiple trading institutions for for the past some time. So, without any further ado, let's deep dive into what this is. So, grab a notebook, get comfortable, and let's dive into the exciting world of high frequency trading system design architecture. So, particularly just to give you a brief idea of what we have already discussed is different components of HFT system design. In that, we started with the data feed handler, one of the components that is taking in the data and passing it according to the requirements that we have. Then the second component that we had was the limit order book. That limit order book we tried to implement with the help of simple arrays in two different arrays, bid arrays and ask arrays, and we allocated as much memory as we can. And the whole thing that we are trying to optimize here is the latency. Be as fast as possible, be as low latency as possible. Now, the third component that we have after the limit order book is the order management system. And this particular component or module manages all the orders sent to the venues based on the signals that are generated by our strategies. It will handle sending, canceling, replacing excess information about executive orders, including pending and open orders. And one thing that we are optimizing since the start is we must send these orders in a very efficient and a cost-effective manner from time perspective. And we would be routing each order depending on a lot of factors that are there. And some of the most common factors are what is the signal strategy, the venue cost, the latencies between different venues, the best price available, and finally the shares or contracts available on each venue. And we need to be smart enough to handle the cases where our order is rejected or cancelled by the venue. It is partially failed, it is fully failed. Because these are cases which can make or break the system that you are designing, and having handled a lot of these different cases or the edge cases is very important when we are designing the system. And based on these different statuses that we receive, our order management system may execute different paths. The fourth component that we have is the strategies. Now, this is the brain of our systems. Strategies will take limit order book from each venue and make defined decisions based on different parameters and values. So this is the brain where each and every company, firm, or the individuals plays one of the biggest role in thinking. Like other than this thing, we are just trying to build a system and optimizing it as much as possible. But after that optimization, strategy is the thing that plays the game of what you will be doing and based on which you will be earning the profit. And strategies could be of a lot of time types, and some strategies will need to analyze the entire depths of books, orders, stop of book prices, best bid and best ask. And in the general sense, you can have infinite type of strategies, and you have to pick the idea that you think is the most profitable one. So one of the things is a simple latency arbitrage strategy that is very widely known by everyone. In that, what happens is each venue, each place receives market information at different times. And if our system can be a little bit faster enough, we can take advantage of these price gaps. Usually these discrepancies last no more than 500 microseconds, but we are going at a very low level of these latencies. And in that meantime, we'll try to take advantage of that arbitrage. And after that, after those 500 microseconds, generally these things are balanced by the market participants. So, for example, let's say, and this is not something new, this is a new thing when it comes to the low latency systems, but this has been going on since a lot of earlier, not when it comes to the electronic trading, these trading systems earlier before when trading used to happen. It also used to happen. And I'll give an example in the coming time. So, for example, in the market, a big institution buy a big, very, very big order of a given stock at $4.50 per share, and then what's available at 451, and based on what the market is like at the moment. Now there is some latency arbitrage that might come into place. And the thing is, when these particular people, when our strategy can see this funds algorithm in the market, and we they have placed the order for that particular thing. Now, by the time their order reach that particular market, what happens is I'll go to the market and buy maybe 100,000 or million shares for $4.50, and my order would be placed before they do. Now, once I've ordered that much, all the orders for $4.50 might be filled $4, and the price might go to the $4.51. Now what happens, and a lot of people might be selling it at $4.52, 53 cents. And now what happens is I'll come back to the market. Now they cannot buy at that price. Now in this meantime, when I have bought the shares, it came to me. Now I would sell that share at $4.51. And the thing is, I have now this company, the bigger institution or the bank would buy that thing at $4.51 because that's what the market price is right now. And if you do that thing for maybe a million shares, then you would have made 1 cent multiplied by a million. And it might not look very much. I think here we have made around, I think, 1 cent for, I think, a million shares, or maybe 1 cent for 100 million. I think we made around, uh, if we had 100 shares of worth 100 million, I think we would have made something like a million there. And the point is, this thing might sound small, but we particularly do this several thousands times per day, and this way we would be adding up millions of dollars per trading day that we have. And most probably it might be billions, several billions per year, but this is how we are taking advantage of simple latency arbitrage. And there are much more complex arbitrage strategies that people take advantage of. Just for trying to make you understand, I took this particular easy example. And for the people who might be having more in-depth knowledge, they might be knowing about this triangular arbitrage, where particularly ha- we have these discrepancies between three currency pairs. And then here also we we try to take advantage of the arbitrage that we have. And before the pricing change across all the three different pairs, we see like where it has changed, and by the time it is changed for the third pair that we have, we try to by the time it came to the arbitrage of the second and the third pair, we try to take advantage of that thing and go there. Finally, that we have once we have order management system in place, once we have decided the different strategies that we have, then a big thing comes into this part, like when it's a software architecture. Until now, if we try to have a look over through what we have discussed is the basic architecture of the system looks like this. There is one limit order book in which the mind that we have is the strategy, and that when we apply that particular strategy, and based on that we go to the order management system. Now, in this particular thing, you would have understood by now that concurrency is the key, and we have it to be working properly up to the mark, and we will use some kind of synchronization standards and a design architecture that particularly fits our needs of low or ultra low latency. And we would be discussing about it's not a very in-depth detailed things about different design patterns that we have, but we would try to have a very high level overview of the different design patterns that we have. And there are a couple of design patterns that are recommended or satisfy our needs. And the first one we would be seeing is the observer design pattern. In this particularly, you can understand this thing as sort of a maybe a notification system in which what happens is for the subject that we have different sets of observers. And in case there is any change in the state of the subject, then that state change is sent as an update to all the observers that we have. So the problem or the bottleneck that we have in this particular design pattern is, let's say for example, we have multiple strategies running on the same system, but the notification process would be processed one by one. It will first notify strategy one to do its calculation, send orders if criteria are met, then strategy two again do the calculation and see if the criteria are met. And it's more of like a sequential process. So that's what we have some sorts of bottlenecks here. So for example, you can just see this particular implementation of how they have applied the observer design pattern. So on the left, they have defined the observer, like how the observer is there. On the right, they have defined how the subject. So if we try to understand what happens is we have a particular subject, and when the state of the subject is changing, we are updating all the observers that we have. So I think here in this thing, particularly the notify method that we have, when the state of the subject changes, this notify is the one that is notifying all the observers that we have. So the order book, in this case, when we have applied this thing, the order book will send notifications once any price has changed so that all the strategies can receive it and act on it. If the strategy meets the specific criteria, it will trigger orders on the exchange, and the process of asserting whether the criteria is met or not could be more or less complicated. And based on how that is implemented, it can take more or less time. So, for example, the bottleneck that we have here is, let's say, uh, for example, strategy one takes a couple of milliseconds to do some fancy calculations. Then, by the time the strategy two gets a notification, it's too late because by that particular time, the markets would have already moved off, and the arbitrage that we might be able to use at in those places might already be gone. So for that, we have a more advanced or more better design patterns. And the second, better pattern as compared to that is the signals and slots pattern. And generally, it is used to communicate between the different objects or the different processes that we have. And the underlying implementation is somewhat similar to the observer pattern, just we saw. But in this thing, I think one of the main differences that we have as compared to the earlier is the implementation of these callbacks and how the event information is passed to the next different processes that we have. And but at the same point of time, this pattern is also derived from an observer pattern. So it has some advantages, but perform in a similar manner to what observer pattern does. And observer pattern is a good thing, but when we are trying to have as low latency as possible, then I think, not I think, in general, we can have much more better design patterns. And one of those patterns is this ring buffer pattern. And in this, we try to have this ring buffer in point of a circular queue data structure. And through circular queue, we are trying to have the first in, first out characteristic, similar to what we have in the queue. And it also has two indices. First is where the process can place from where process can read, and the place from where it can write. And this kind of structures are generally cost lock free, and its performance is beyond any other patterns that we have discussed till now. And I think what you see here right now is kind of a implementation of the LMAX. So, so for example, like how it's mentioned here also, one of the big adopters of this pattern is LMAX with its distributor. So I think the design that you see on the screen is the LMAX with its disruptor in which there is a receiving end, then there's a business logic processor, and there is a publisher end to this thing. There's an input disruptor and there's an output disruptor. So in all, it is a LMAX with its disruptor. And this kind of pattern is ideal for socket communications where serial data has to be managed. So in this case, it's not suitable either for our trading architecture. And in the next session that we will be having, or the next part of this series, we would try to understand what architecture we would be using for designing an ultra low latency systems that we intended to build. So for those who have been watching till now, I thank everyone. And in case if you have any comments or any feedback or any doubts, please let me know in comments. And thank you for being till here. Let's see you in the next series that we have.